Imagine paying, I don't know, $9 for an API call that used to cost you maybe 10 cents.
Right.
And then, discovering that this massive price hike is actually somehow saving your company thousands of dollars a month.
It sounds completely backwards.
It really does. But that is the bizarre mathematical paradox sitting at the absolute center of the AI industry today. So welcome to this custom deep dive engineered specifically for you.
Yeah, we have a really dense stack of sources today.
We do. We are looking at Google's official architecture announcements, some heavily detailed independent benchmarks from artificial analysis, and these really comprehensive technical reports spanning late 2025 to 2026.
And every single one of these documents is zeroing in on one industry-shaking release.
Right. Gemini 3.5
Yeah.
Flash.
Yeah.
Our mission for you today is to cut through the marketing, because there's a lot of it. We need to figure out if Google's sweeping claim that they have somehow fused frontier-level heavy compute intelligence with lightweight zero latency speed, if that is actual reality.
Or just, a masterclass in benchmark hacking.
Exactly. Because if they have actually pulled off this Pareto frontier shift, the way you architect applications, the way you allocate compute budgets, and how you interact with agentic systems is about to just completely change.
It's a total paradigm shift.
Okay, let's unpack this.
Oh, wait.
No ellipses. Okay, let's unpack this because I am beyond excited to dig into the architectural shifts making this possible. Let's talk about the speed first.
Yeah, so to appreciate the severity of this shift, we really need to look at the historical taxonomy of the Flash designation. Like, what did Flash actually mean before this?
Right, because the Gemini ecosystem used to have this very rigid physical law, right?
Exactly. The Pro models were your massive, dense transformers. They were handling deep reasoning, but at high latency. They were slow.
Heavy and smart.
Exactly. And Flash models were your distilled, highly pruned networks. You deployed Flash for low latency routing, simple categorization, or basic text generation.
Light, fast, and kind of cheap.
Right, and you fully accepted that it would fail at complex multi-step logic. But the technical reports for Gemini 3.5 Flash suggest that Google has effectively detonated that boundary.
Like, completely erased it.
Yeah, they're claiming heavy compute capabilities running on a lightweight infrastructure.
And the raw numbers on the speed side of that equation are staggering. I was looking at the artificial analysis benchmarks, and they show Gemini 3.5 Flash pushing out 277 to 289 tokens per second.
It's absurd.
We'll just call it a baseline of 280 plus for our discussion. But to put that in perspective, this model is roughly 4 times faster than rival frontier models.
4 times.
And critically, it is 70% faster than the previous lightweight iteration, Gemini 3 Flash.
Which was already fast.
Right. When you are generating a, say, 200 or 300 word response, it is rendering in literally fractions of a second. It completely eliminates that streaming UI paradigm.
Yeah, the text doesn't chunk across the screen like we're used to.
Right. The entire block just instantly populates. That kind of reminds me of an analogy from one of the sources, like interacting with old AI models was like driving a reliable family car, It got you there eventually.
Sure.
But Gemini 3.5 Flash is like suddenly being handed the keys to an efficient hypercar. It's just instantaneous.
What's fascinating here is the underlying mechanism that enables that leap. Hitting 280 tokens per second isn't just about throwing more raw silicon at the problem.
It's not just bigger server.
No, not at all. The 2025-2026 architecture reports point to a highly optimized mixture of experts, or MoE, routing system.
Okay, break that down for us.
Well, instead of activating every single parameter in the model for every single word, which is incredibly inefficient, the system is ruthlessly efficient at passing the computation only to the specific neural subnetworks required for that exact token.
So it's only using the parts of the brain it needs in that exact microsecond.
Exactly. Combine that with advanced speculative decoding, where the model drafts multiple future tokens simultaneously and verifies them in parallel, and you get this massive reduction in inference latency.
And that architectural efficiency, it compounds explosively when we move out of a simple chatbot interface and into full agentic flows.
Oh, absolutely.
The sources highlight tests running on anti-gravity 2.0 frameworks. In those environments where the system is independently searching, validating, and course-correcting its own logic loops, Gemini 3.5 Flash isn't just a little faster.
It's a whole different ballgame.
Right. It operates up to 12 times faster than legacy models. 12 times.
Because latency in an agentic loop acts as a severe tax on time. Like, think about it. If an agent has to execute 40 sequential reasoning steps, and each API call takes 2 seconds of processing overhead, your application is hanging for over a minute while the agent thinks.
Which feels like an eternity for a user.
Totally. By dropping that inference time to a fraction of a second, that same 40-step logical chain resolves almost instantaneously. At scale, for a developer running thousands of asynchronous agentic tasks, this completely redefines what is viable to automate.
Wow. But, speed is great, but a fast car is completely useless if the driver doesn't know where they're going.
Fair point. A fast failure is still a failure.
Exactly. The core of Google's claim is that they have packaged frontier-level intelligence into this hyper-fast architecture. Let's look at the context window, because this is where the brains really show up.
Yeah, the 1 million token working memory.
Right. Gemini 3.5 Flash maintains a massive 1 million token context window, and we know how computationally expensive it is to maintain attention across a million tokens.
Historically, it's been a nightmare.
Usually the model gets sluggish or it suffers from that lost in the middle phenomenon where it just forgets the data in the center of the prompt.
But the technical papers outline how they actually solve this. They are utilizing advanced key-value caching mechanisms, specifically continuous KV cache state updating.
And that allows it to hold the context without dropping speed.
Yeah, it allows the model to retain massive amounts of context without having to constantly recompute the attention scores for every new token generated.
Which is huge.
It is. This is what allows it to ingest dense, multimodal payloads like massive raw video files, hours of uncompressed audio, highly complex PDFs, and process them all simultaneously without the latency just spiking through the roof.
And the artificial analysis benchmarks, they validate that multimodal capability beautifully. They reference the ChartChef benchmark.
Oh yeah, that's a brutal test.
Very brutal. It tests an AI's ability to parse and reason through highly complex, multi-layered scientific charts and graphs. Gemini 3.5 Flash scores an 84.2% on ChartChef.
Which is wild.
Right. This isn't just basic OCR text extraction. The model is natively mapping visual data points and text data into the exact same latent space. It is actively outperforming the heavier, older Gemini 3.1 Pro model in both visual logic and complex coding benchmarks.
If we connect this to the bigger picture, you really start to see the death of the bridge model architecture.
Bridge model.
Yeah, so older systems used to rely on secondary models to translate an image into text embeddings before the main language model could actually reason over it.
Oh, like taking a picture and making a caption, and then the AI reads the caption.
Exactly. But that translation layer inherently degraded the nuance of the data. Gemini 3.5 Slash processes natively across modalities.
It just understands the image itself.
Right. And the architecture allows for flexible compute scaling, which they call thinking levels.
Oh, I saw that.
Yeah, it allows the model to dynamically allocate more processing power when it detects a highly complex logic puzzle within that multimodal prompt.
And that dynamic scaling is what enables its multi-turn retention. The ArcSwift reports confirm that in a full 1 million token session, the model achieves near-perfect recall.
It doesn't lose the thread.
Right. It isn't just answering isolated queries, it is holding on to complex reasoning, retaining its own logical deductions from turn 1 and applying them to turn 50. For you listening, imagine feeding the model a massive, disorganized repository of user telemetry data, server logs, hours of video, and you can just have an ongoing high-speed dialogue.
Getting a synthesized, accurate breakdown instantly.
Yeah, the AI cross-references those massive data sets instantly, maintaining the entire context of your investigation. It takes the friction entirely out of large-scale data synthesis.
And it does all of this while supporting highly structured outputs natively. It forces the data into perfect JSON schemas or relational tables without requiring massive prompting overhead. The intelligence isn't just in the reasoning, it's in the structural discipline of the output.
Which, okay, brings us to the elephant in the room.
I know where you're going with this. Cost.
Cost. Because we have hyperfast inference powered by speculative decoding, we have native multimodal embeddings, and we have a million token context window with near-perfect recall. Historically, in the tech world, when you stack that much premium architecture into a single release, it's going to drain your wallet. The pricing usually scales exponentially.
Oh yeah. The pricing structure is easily the most scrutinized element of this release.
Let's look at the official global tier pricing. Here's where it gets really interesting, because the math feels aggressively counterintuitive based on the marketing.
It really does. Looking at the raw numbers, the developer community was initially very, very skeptical.
And for good reason. The official cost is 1.50 cent per million input tokens and a staggering $9 per million output tokens.
$9.
Now, Google is heavily pushing a 90% discount on cached input, bringing that specific metric down to roughly 15 cents. But if we strip away the caching discount for a second and just look at the raw compute cost, it is roughly 3 times more expensive than previous Flash models.
Yeah, legacy Flash models were operating at around 10 to 50 cents for input.
So I have to push back hard on this. Google is out there claiming this model is often less than half the cost of its predecessors. But if my output cost has jumped to $9 and my uncached input is $1.50, how on earth is that not just a massive price hike disguised as an upgrade?
I get it. That pushback is entirely justified if you look at the pricing model through the lens of legacy development.
Okay, what do you mean?
If you treat Gemini 3.5 Flash like a dumb text generator where every prompt is a discrete, isolated API call, your costs will completely skyrocket. The half the cost claim relies entirely on a fundamental shift in workload efficiency.
But wait, caching only works if I'm sending the exact same prompt over and over. If I'm building a dynamic application for you, say a customer service portal where every single user is asking a highly unique question, that 90% caching discount is pure vaporware.
Right.
I can't cache unique user queries. So I am stuck paying the premium input rate, and I am definitely stuck paying that massive $9 output rate.
You are absolutely correct that you cannot cache unique user queries, but that sort of misunderstands where the compute weight actually lives in modern architectures.
Okay, explain that.
In a sophisticated application, the unique user query is maybe, 50 tokens?
Sure, where's my refund?
Exactly. The massive computational weight is in the system instructions and the RAG infrastructure, the retrieval augmented generation payload. You might have an 800,000 token database of product manuals, company policies, and historical logic trees that the AI needs to reference just to answer that tiny 50-token user query.
Oh, I see, yeah.
Under the new system-level shared prefix architecture, you cache that massive 800,000 token payload once. That massive block of data gets the 90% discount, bringing its cost down to 15 cents per million.
Okay, so the bulk is discounted.
Right. When user A, user B, and user C all ask their unique 50-token questions, the model doesn't reprocess the 800,000 tokens. It retrieves the cached state instantly, and you only pay the premium uncached rate on those 50 unique tokens.
To put that into an analogy, it's like giving the AI a massive open book test. In the old system, every time a new student asked a question, the AI had to speed read the entire 1,000-page textbook from scratch before it could answer.
Exactly.
But now, the AI has pre-read the textbook, pre-highlighted the exact passages it needs, and locked that state into its short-term memory. When the unique question comes in, it just references the highlighted notes.
Precisely. The computational heavy lifting is done once and amortized across thousands of queries.
Which makes total sense.
But the efficiency extends beyond just caching. Because the frontier-level intelligence natively understands complex logic on the first pass, the total volume of necessary API calls drops drastically.
Oh, because you aren't doing the back and forth trying to fix its mistakes.
Right, you aren't burning millions of tokens on error correction loops, reprompting, or validation layers. You buy fewer tokens, but they yield a much higher success rate. So the total workload cost plummets, even though the unit cost for the individual output token is $9.
Wow. That structural shift is profound. It really forces developers to move away from brute force prompting and toward highly optimized context management.
I'm too adept.
Yeah, but we do need to ground this excitement in reality because reading through the technical reports, it is clear that this system requires rigorous infrastructure to actually hit these idealized efficiency numbers.
Yes, there are hard limitations you need to navigate.
Knowledge cutoff, right?
That's the most immediate constraint.
Uh-huh.
The native training data for Gemini 3.5 Flash terminates around 2025.
Okay.
If you are building applications that require real-time market data, breaking news, or post-2025 library updates, you have to inject that context natively through your RAG pipeline. The model will not know it inherently.
That makes sense. The sources also highlight the lingering issue of residual hallucinations.
Right, the AI still lies sometimes.
Exactly. The advanced Mo routing and speculative decoding have vastly improved logical coherence, but they haven't achieved a zero hallucination state. The AI will still occasionally output statistically probable but factually incorrect assertions with extreme confidence.
Which is dangerous.
Very. If you are deploying this in critical workflows like legal contract auditing or medical diagnostics, you cannot just blindly trust a 280 token per second output. Human-in-the-loop verification is still a strict requirement.
This raises an important question about deployment logistics, like how can developers and users practically navigate these hurdles? Because the incredible pricing and speed we just broke down are heavily gatekept by Google's infrastructure tiers.
Yeah, the benchmarks explicitly note that pricing and rate limits vary drastically depending on whether you are operating in a global tier versus a non-global tier.
Which is a huge catch.
It is. If you are geographically restricted or operating in a region where Google's data centers haven't fully rolled out the 3.5 caching architecture, your rate limits might be so heavily throttled that you can't even maintain a massive shared prefix cache effectively.
You might literally get timed out before you can leverage the discount.
Which defeats the whole purpose.
And, you are not operating in a vacuum. The artificial analysis benchmarks clearly position Gemini 3.5 Flash against a violently competitive landscape.
Claude 4.7 and GQC 5.5.
Exactly. They are actively racing against it, heavily optimized for this exact same low-latency, high-reasoning Pareto frontier. The entire industry recognizes that the future belongs to models that can act as frictionless, instantaneous logic engines.
So, bringing all these threads together, how do you practically navigate this transition? Based on the source data, your immediate roadmap for everyone listening is pretty clear.
Yeah, what's the game plan?
First, do not blindly migrate your entire stack, assuming an instant cost reduction. Use the free or limited API tiers to run A/B testing on your specific data payloads. Prove the workload efficiency in your own environment.
Start small.
Right. Second, rebuild your prompt architecture to maximize those system-level shared prefixes. Front-load your static data, cache it to get that 15-cent rate, and keep the dynamic user inputs as small as possible.
Which is just good practice anyway.
Exactly. Third, leverage the native structured outputs. Force the model into JSON schemas immediately to cut down on parsing errors down the line. Finally, be surgical with the flexible thinking levels.
Keep the dial low.
Yes, keep the compute dial low for standard routing and categorization to maximize your ROI, and only trigger the deep reasoning pathways when the system detects a complex logic anomaly. Treat the model like a precision instrument, not a blunt force tool.
Because when you optimize your infrastructure to match this architecture, the friction of development largely disappears. We are moving from a paradigm where compute was a scarce, slow resource that had to be carefully metered into an environment where high-level synthesis is just functionally ambient.
So what does this all mean? When we aggregate the 2025-2026 technical reports, the raw speed benchmarks, and that complex pricing paradox we broke down, the picture is incredibly clear.
It really is.
Gemini 3.5 Flash is not just an iterative speed bump. It is a fundamental democratization of frontier-level intelligence for massive, large-scale production.
Yep.
By combining advanced MOE routing, continuous KV caching for million-token context, and shared prefix economies, it allows you to run heavy compute logic at a scale and speed that was physically impossible just a year ago. It drastically lowers the barrier for experimentation and faster innovation for everyone listening.
But, the democratization forces a very uncomfortable evolution for us as operators.
Oh, how so?
Well, if we accept the premise of these benchmarks, that systems can now synthesize vast amounts of multimodal data, hold near-perfect recall over 1 million tokens, and execute complex agentic logic at 280 tokens per second for pennies on the workload dollar, it presents a profound shift in utility.
Okay, I'm listening.
For you listening, think about this. If generating deeply intelligent, highly structured answers is now functionally instantaneous and practically free, does the inherent value of human work completely shift away from having the answers and entirely toward our ability to construct the right, unseen questions?
Wow, yeah. As the architecture handles the heavy lifting at the speed of thought, your distinct advantage is no longer the ability to process data. It is the vision to point that immense capability in the right direction. Thank you for joining us on this deep dive. Take these architectural insights, restructure your pipelines, test the very limits of these caching mechanisms, and above all, stay insanely curious. We will be right here waiting to unpack the next paradigm shift with you.